Good morning, all of you. So, I welcome you all to day 7 of our 3-week summer training program on Geospatial technology. So, we are Northeast Center for Technology Application and Reach, headquartered at Shillong. This is a very brief intro about Nectar. So, today's agenda, today we are having a case study on water-induced disasters. So, the topic is studying water-induced disasters and climate risk in Brahmaputra Valley, Assam. Basic concepts, issues, and scope for application of geospatial technology. So we have a very senior speaker with us, Dr. Partha Jyoti Das. He's the head Water Climate and Hazard Division, Aran Nayak. He's having more than 20 years of experience of doing research and advocacy and imparting education in climate variability and change, water and climate induced disasters, disaster risk reduction, climate change adaptation, resilience, socio-hydrology, eco-hydrology, wetland, ecosystem services, water quality, environmental and social impact assessment of development interventions, environmental governance and policy, water conflicts, transboundary water and river management, natural resource management, environmental mitigation and application of geospatial technology in environmental research and thematic areas. He has more than 25 research and action research projects funded by various national and international donor agencies. He is also a member of steering committee of Forum for Policy Dialogue on Water Conflicts in India, the the most prominent water think tank of India based in Pune, India. He is also honorary senior fellow of Asian Conference, a regional organization for socio-economic development, cultural integrity and ecological security of South and Southeast Asia. He is also a member of expert committee constituted by Government of Assam for rejuvenation of river Kolong, Assam. I also had the wonderful opportunity of working with him for a very brief period of 2 months when Partha sir was posted as advisor in our Northeast Center for Technology Application and Reach. So I know how much knowledge he is having with them and the experience that he is carrying with him. And with him we have another speaker from Aranayak, Sri Arav Kumar Dasji. He is Senior Manager Geospatial Technology and Application Division, Aranayak. He has more than 14 years of experience in field of geospatial technology and application areas. He has experience in the field of wildlife research through the application of geospatial technology. He is also trained to Forest Department on basics for remote sensing and GIS and GPS technology. He is also a guest faculty at Central Academy of State Forest Services, Barnihart. Now I request Sri Dharmender Kumar Jha, Senior Analyst, to facilitate our first guest speaker for today, Dr. Partha Jyoti Das, in the traditional Assamese style. Now I request Sri as Ms. Panjuma Kotaki to facilitate Sri Arup Kumar Dasji in the traditional Assamese style. Uh, Thank you, Sri Dharmender and Ms. Kotaki. Now I hand over the mic to our first guest speaker for today, Dr. Partha Jyoti Das, to start the proceedings. Thank you.
Thank you. A very good morning to all of you, my dear participants, my former colleagues of Nectar, and my present colleague, my friend Arup Das. So it's a delight to be able to come to this program. And thank you, Nectar, for inviting us, both me and Arup. And by doing that, you have given us an opportunity to share some of our experience of working on subjects where geospatial technology is profusely used. And in this kind of presentation, which is a joint presentation by me and myself and my Arup and I, we will be trying to give you a very fundamental ideas of some very important concepts of disaster management, and how we explore those ideas on ground, on field, and how in some cases, wherever possible, we try to represent the results using various types of mapping. And mostly, mapping is done using geospatial technology nowadays. So I will try to wrap up my part of the presentation within how much time do we have together? How much time? Huh? Acha, we have planned only up to lunch time, huh? By the way. The rest is free. Let the students go. So I think I will confine myself to say 1.5 hour, not more than that. Don't want to give you too much a dose of theoretical knowledge. In between, I will refer to wherever it is relevant, some special cases of mapping and other aspects of geospatial application. And in his part of the presentation, Arup will talk in detail about the entire procedure that we follow for mapping. Aranyak has a full-fledged geospatial lab. We call it GITA, Geospatial Technology Application Division. Arup is the manager. So there are many many aspects of environment that we work on. For example, forestry is a big area, wildlife conservation is a big area, livelihoods, and then the whole gamut of disaster management, climate change, and all that. And there is hardly anything left where we don't use one or the other kind of application of geospatial, because the scope is so large, and everywhere almost you can find an opportunity to apply remote sensing GIS if you want to actually. So Arup has vast knowledge of working hands-on and then so together we have done a lot of work, and one or two case studies that we have done will be demonstrated here, just to give you a glimpse of how we did it actually, and how it can be done, how it should be done actually. Also, I am giving some examples of how it should not be done, right? Both aspects of, there are many examples of mapping things in a very wrong way, right? So to start with, since if you have noted, English is fine, na? The only language, or you want me to speak in Hindi also to some extent? English is fine? Good. So if you have noted, we have kept the title as Studying Water Induced Hazards, right? Studying means we will talk about concepts, ideas, methodology, field work, etc. So we will start with some basic concepts of disaster management. Actually, my part will focus mainly on conceptual aspects, and how in some cases ourselves and different other authors, other people have represented those concepts in the form of maps, and I will try to analyze the pros and cons, merits and demerits of whatever has been done. So, here the other word that I have used is climate risk, because nowadays there is not anything in the environment, in the physical or natural environment, which is not affected by climate change. So, you can't describe water induced disasters, or alternatively you call them hydrometeorological disasters which originate from the hydrological cycle, right, from through interaction of the atmosphere, land and water. We call land, water, atmosphere interface. These three interfaces are all the time interacting with each other, therefore, you have this hydrological cycle, right. And as a result of this, you have weather, formation of cloud, we have our atmosphere, troposphere, stratosphere, right, ionosphere, we have a ozone layer, high school science, you will remember everything. So, weather is formed basically in the troposphere, and this is what determines more or less the entire atmospheric environment or climatic environment of the planet Earth, and therefore, we call it climate. We have weather, we have climate, these are very important terms. It may not be possible to explain each and every term, but we will keep sufficient time for question and answer. So, if you want to know, then we can discuss, but during my main presentation I may not be able to touch all aspects of these basic concepts. So, I will explain about a few critical concepts which I am sure most of you may not be familiar with at that level, right, but I am assuming that all of you are familiar with climate change. So, I am not going to repeat anything about climate change, because this has become general knowledge, right, but I will very often refer to climate change impact and climate risk. Now, we call it water induced disasters. So, we will start with what is a disaster. Any idea? It will be little bit interactive. As I said, my whole purpose is to familiarize you with some very basic concepts, and then only I will go to their spatial representation, etc., other aspects of it. So, the terms that we are using in English language, they are very common words and terms that we keep using in our daily life, but when we use in a very common way in our conversation, they carry a different meaning, which we call the literary meaning, which you find in the dictionary, right, Oxford English Learners Dictionary, any kind of dictionary. But when we use the same term or word in disaster management science, they may carry a different meaning, and sometimes a fundamentally different meaning, right. So, it is interesting, I think. I am using standard definitions of some terms which have been picked up from the IPCC 6 report. Now, what is IPCC? There is an international body of scientists, international platform of scientists, climate scientists, who are doing the most advanced and frontline research and documentation of the advances being made in climate change science. This is a wing created by the United Nations. It's called IPCC, Intergovernmental Panel on Climate Change. Every 4th year it brings its report, and all of us wait very eagerly. So, the last IPCC assessment report 6, it came, the first volume came in 2021 later part, and the other volumes have been published in the earlier part of 2022. So, IPCC, if some of you want to follow climate change in your career later on, so you better, you have heard about IPCC, right? So, if you want to learn climate change in a scientific way, please follow IPCC literature. So, IPCC reports, it may not be possible for all of you to understand everything, but keep trying actually, right. So, I have picked up these definitions from IPCC. They look a little bit difficult when it appears for the first time. You may not be able to make anything out of it, but then for the sake of accuracy of definition and reliability of information, I am not resorting to easier definitions. When we explain, we will make it as simple as possible, but when we put it on writing, these are very standard definitions that the entire scientific community follows. So, it may be an occasion for you to know something new, right, that how IPCC defines hazard and disaster, and what we actually mean by hazard and disaster. So, it is going to be fun. Let me try actually. I have been trying this for a long time, and it is not always a very pleasant experience, but always the students at a later point of time said that it was very, very, very useful. They understand it after 6 months or after 1 year. So, these are the basic questions we will try to explore today. Water induced disasters, what is climate, what is climate risk, how do they interact to make people vulnerable. So, you have another term called vulnerable or vulnerability, and how do you study the impact of water induced disaster and climate risk interacting with each other. And then spelling mistake, how can we use geospatial technology in exploring water induced disaster and climate risk which is observed on ground. Learning something theoretically, conceptually, part of your curriculum in any subject, textbook kind of work, and then exploring the meaning of these all ideas and concepts as they are happening on ground and affecting people. It's a completely different aspect of this, but we are trying to combine them. So, the basic concepts, I am not going to discuss each and everything, right, and part of this presentation I will make available to you, so you do not have to note down anything, just concentrate on it. Barring a few maps which are still under construction or we are using for publication, cutting that off, the entire presentation will be made available to you, right. So, these are some very important concepts of disaster management science, or people call it differently. People also call it vulnerability science, people call it disaster risk management science a lot. These words are very key concepts. I will explain only 4 or 5 only. I just want you to know: hazard, vulnerability, disaster, exposure, impact, risk, coping and coping capacity, adaptation, adaptive capacity, resilience, transformation. Are you familiar with these words? Have you heard about these words? You know, no? At least the dictionary meaning you know, right? In our regular conversation, we very much talk about weather, climate. Oh, what a weather is changing, climate is becomes so hot. oh, it was a disaster, right? Assam is a hotspot of disaster, you know that, right? Then somebody will say, no, somebody will say that in newspaper you will get, oh, it was so hazardous, it was a big hazard. Then if you are, listening acutely, attentively, you will be confused. Somebody said it is a disaster, somebody said it is a hazard, what is this, right? And very often we use these terms in our daily life. We call that, oh, he is so vulnerable, don't take risk. Can you cope with this crisis? Can you adapt to that change? Oh, you have to gain resilience. All terms that we use in our daily life, but the same terms acquire a very different meaning when you use it in science, right? Now, I just wanted to make you speak, make you, open up, come to the very basic word called hazard. What it means to you? What does it mean to you? Give me your own sense. Don't think critically about it, or don't think about scientifically. Just tell me what, when you say hazard, what it means to you. Loudly. Danger. Okay. Close to the meaning. Yeah, of course. If there is something dangerous, you call it, could be hazardous, right? It could be a hazard. Anything else? Anything else? Give us just English literary meaning. That's all. Hazard. What kind of thoughts does it trigger in you? The word hazard. Right? In Assamese, durjog. In Hindi also durjog. Apada. Okay. Say something, otherwise how do I know? Because the definitions are going to be very, they're not going to be simple. Just tell me what you understand by hazard. English, simple English meaning. Okay, good. So why were you silent so long? Okay, you have covered a lot of ground, man-made and natural, both types of calamity. I will add that word to this list. Another word, calamity. Anyway, hazard, it's a synonym to hazard. So, right? There are other words, catastrophe, calamity. They are used qualitatively, but actually when it carries the signs we call them hazard. They are equivalent word. We don't define calamity or catastrophe. We let Oxford English Dictionary take care of it. In disaster management science, we call it hazard, and others are synonyms, equivalent. So, yeah, anybody else? Very good, very good. This is a broader definition. Yeah, this is a broader meaning. Anything that, okay, fine. This is correct as far as your literary meaning is concerned. But when it becomes a scientific term, you have to say anything that may create difficulty. Not that creates difficulty, that may create difficulty for some people, or for we usually call systems, right? We call natural systems or natural ecosystem or socio-economic system. anything which is created by human beings, we call them socio-economic system. In system science or in system thinking, we treat all of them as systems. So, in natural anything that may disturb the normal functioning or normal situation of a natural ecosystem or natural system or a socio-economic system may be termed as an hazard, right. That is a simple correct meaning, right. But scientists are not happy with anything simple sometimes. They have very wired ways of defining things, right. I will read it out, I will not take much time. I will do this experiment with 2-3 terms and then leave others for you. It says the potential occurrence of a natural or human induced physical event or trend that may cause, underline may, loss of life, injury or other health impacts as well as damage and loss to property, infrastructure, livelihood, service provision, ecosystems and environmental resources. A full definition of hazard. Now, let me tell you, these definitions have evolved through at least 5 decades of time. So, at various points of time, international agencies like IPCC, like UNISDR and many other scientific groups have been defining these concepts differently, but the core meaning has remained same. But then, like everything else, science always improves and evolves and improves, right. Any subject, any discipline improves, gets upgraded and evolves like a software, right. So, these definitions have evolved. After 4 years, IPCC may change 1 or 2 other words here, so that will become a new definition. But a lot of thinking has gone into these definitions, right. So, just go through it and see if you agree or not, right. So, it gives you the impression that something, a phenomenon, an event, a happening, an occurrence that has the potential to disturb you and your life, to disturb wildlife, nature, anything. What you need to remember is that not it has the potential, means it may disturb you, it may jeopardize, right, it may affect you, right, it may not affect you, that means it may not affect you too, right. So, in general, in our normal life, we use the word hazard and disaster interactively. Either we say hazard or we say disaster, but in science, they have a little bit different meaning, right. So, hazard is anything that has the potential to disturb you. When I say you, means any system, it may not disturb you too, but the moment it has happened that it has really disturbed you, that means you were vulnerable to that hazard, and by being able to disturb you, that hazard has become a disaster. You got the difference, right. A hazard is something which is waiting to be a disaster, it has not yet become a disaster. Depending on whether it has affected you or not, it will become a disaster. That is the difference. So, now you understand hazards and disasters are different, and therefore, when you come across a hazard map and a disaster map, be careful. Usually, mostly you will come across, and that is what we also do, we prepare hazard maps. very rarely you will find disaster maps, right. It is there, there is a very elaborate work you need. So, when you prepare a hazard map, your approach is little bit different. When you prepare a map of disasters, your approach will be different, because they differ fundamentally, right. That is it. Was it very difficult? No, it is not that difficult, right. But when you go through the definition, at the first appearance it may appear to be difficult, but never mind. I have taken about 20 years to become familiar. I am still finding some of these definitions difficult to understand and to explain. So, it is not that easy also, right. So, good that you have come to know something new, right? That is important. This is another term called exposure. अभी बताओ, what do you mean by exposure? Same exercise. Tell me its dictionary meaning, I will tell you its scientific meaning. So, there is lot of heat wave going on in North India, right? The last 2 weeks, not this week, the previous week was very hot in Guwahati. People are talking about heat waves. I was asked by All India Radio to give a talk on heat waves. So I said, no, heat waves have not yet come. Scientifically, heat waves are, what you mean by heat waves are almost double the severity of this 38, 39 degree, right. We got 38, 39 up to 40 degrees centigrade, and the advice to the elderly and the children is that don't get exposed to heat, right. Don't have an exposure to heat, that will harm you, especially for elderly people and for babies, children. So, what do you mean by exposure? Exposure means getting exposed to something, right, allowing something to penetrate you, something to affect you, right. That is it. Let us see how exposure is defined in climate science. One of you please read it out. Read. This is a good habit. Just read it out loudly. The first one you just loudly. I am just trying to make you interact. That's all. Nothing else.
The presence of people, livelihood, spaces or ecosystems, environmental functions, services and resources, infrastructures or economic, then social or cultural asset in places and setting that could be advisably affected.
Okay. So don't bother about its meaning. You will have to read it couple of times before you absorb the full meaning. But what it says is that the presence of certain things, right? The presence of people, anything that can be affected, people, birds, animals, right? It can be inanimate things also. It can be a house, it can be a hill, it can be anything, The presence of people, livelihoods, species or ecosystem, environmental functions and services, right. Any resource, any natural resource, any infrastructure, it can be a house also, right, or anything, any economic, social or cultural asset. In such places and settings, that could be affected. By whom it is different, that could be affected, right. So, if your residence is, how many of you are in you are from Guwahati? Oh. What is the most and worst flood prone location of Guwahati? Have you heard of these infamous names called Anil Nagar and Navin Nagar? They have become very infamous throughout the world, because for last 20 years they have been consistently subjected to floods, and these are not poor people, these are very rich people getting flood affected every year, and many people are now actually living those two localities. So, living in Anil Nagar or Navin Nagar, by living in these two localities, you are getting exposed to flood, because it is almost near certain that these two localities are going to be flooded in the next season, again in August I am predicting, right. So, as I said, by exposing yourself or by presenting yourself too much of a hot sun, right, you are getting yourself exposed to possibility of a heat stroke, right. So, it means something that could affect you, right. Say if there is a tsunami in Indonesia, are we going to be affected here in Assam? But some people who are living in the coastal areas of Indonesia may be affected, right, because they are there at the epicenter. They live within the what we call sphere of influence of that event. So, that is exposure, right. So, finally, we come to this very important word called vulnerability. You must have seen and you will be seeing a lot of vulnerability maps being prepared, and there is a whole lot of methods, methodologies of using remote sensing, GIS, GPS and other. They are not enough, you have to have your own field techniques to prepare vulnerability maps, but you have to understand what is vulnerability. You tell me what is vulnerability. Same thing. What does it mean to you? English meaning, dictionary meaning. Good, good. Almost correct. Anything else? Vulnerability essentially means that kind of condition or situation. If you are in such a situation, or you are in a particular situation where you may be affected, there is a possibility that you will be affected. That means you may be affected by some stretch or event or phenomenon within bracket hazard. So, to give you a very simple example, say I am a person, I am very allergic to dust and carbon soot. The moment I gain exposure to dust or carbon soot, or I enter a dirty room, I start sneezing. I am allergic. Many people have food allergy, right? The moment they eat something, they face some kind of reaction and all that. That means I am vulnerable to something. The moment I present myself in that situation and I gain an exposure, it affects me, making me vulnerable. So, my condition or my situation is such that that particular phenomenon can affect me, but the same thing may not affect you. That means you are not vulnerable. If you are a very healthy person, remember the experience of COVID? Everybody was not equally vulnerable, right? Some people did never have COVID. We call them having a lot of immunity. Huh? You remembered about immunity? Immunity means something else medically, but in our daily conversation, immunity means nothing will happen. He's very healthy. He's very immune. Well, however strong coronavirus is, COVID-19, उसको कुछ नहीं होगा. He's very immune. He is not vulnerable. People like me, I thought I would almost every month. I thought I would probably fall sick every month. But in the whole 2 years time, I got COVID only once, and I believe that that was also a result of an instrumental error. They kept me confined to home for a week. So then I slowly gained confidence, and I am not as I thought, mainly because I took a lot of care, right? So vulnerability is a condition which can change. It is relatively more or high, right? You can be more vulnerable to something. People who run on motorbikes, there are many youngsters now who like to play stunt on the highway with motorbikes even without wearing, right? Very risky, isn't it? So they put themselves in a very vulnerable situation. Anything can happen. Anything can happen. They may meet an accident and die, right? So you are making yourself or you are finding yourself in such a situation where you are supposed to be affected by something. That vulnerability can be inbuilt in a system, that can be acquired through good habits or bad habits, whatever it is, right? So now you combine these two words, hazard, exposure and vulnerability, right? So you may not be affected even if there is a hazard. To be affected, you have to be vulnerable. So if there is a hazard in place, and if there is me with all my vulnerability exposed to that hazard, open to that hazard, waiting to be affected by the hazard, then I am affected because I have exposure, I am vulnerable and there is a hazard. The combination of these three makes me affected, and then this hazard becomes a disaster, right? As simple as this, right? So every hazard is not disaster. A hazard becomes a disaster when there is something that it can affect, and that something has that kind of vulnerability so that it affects it, and of course an exposure. Example, say there is a flood in a jungle, in a forest, and there is a flood, and for a few hours, and then the flood recedes. This is the type of flash flood we keep on experiencing. and there is no human being actually living on that river, around that river. The flood generates, the flood recedes. No human being is affected, right. So, for a human being living say 5 km away from that river, they will say that the flood was there, but we were not affected because they did not have the exposure. But if there were some household right on the bank of the river, they would have the exposure and they would be affected, right. They will not be affected. There is a hazard, there is the exposure. Even then, if you do not have vulnerability, you will not be affected. Means you are residing on a river bank, there is a flood, hazard is there, flood is the hazard. You have exposure, you were living just on the river, right. But you are living on a very robust tilted house, 2 stories. Flood will not inundate you. Flood will rise at best to the first story, the second story will still remain. That is an ideal situation, just to make you understand. You are still flood proof. The hazard is there, the exposure is there, vulnerability is not there. So, that flood is not disaster for you. Getting na? So, every hazard is not disaster. It all depends whether you are exposed to or not, whether you have exposure or vulnerability, right. If you are vulnerable, then you are bound to be affected. Now, you need to unpack this is a very meaningful word called vulnerability. You have to unpack it further, and this is important, because in disaster management, if you want to do anything of mapping, a lot of mapping can be done in disaster management representing various dimensions. So, vulnerability is one of those, very important. What makes you vulnerable? What makes you vulnerable? All those attributes or qualities need to be analyzed. For example, we are talking about water induced hazards or disasters. It is better to call them hazards. That is the main word. They may not be disaster unless they meet with vulnerable people or systems, but I am intentionally using the word disaster because on ground they are all disasters. You hardly find a situation where a disaster is hazard. They start as a hazard, they immediately become disasters, because all around you will find vulnerable people, vulnerable situation, vulnerable ecosystem, everything is vulnerable, because they do not have the capacity to withstand the impact of that hazard, right. So, vulnerability depends on a lot of attributes, and most important attributes that determine vulnerability are actually socio-economic in nature. Giving example again, think about the ongoing floods in Assam. You know about that, huh? You know that there were big floods in Assam? You don't know? You know? Okay. Tell me confidently, na? So, what do we observe? What did you observe? Many people got homeless, many people, lakhs of people are, the largest population in history has been shifted to, that is government claims, shifted to shelter camps. Lakhs of people are living, many people have gone to their homes, they are still living. People are on relief materials, they have lost their crops, they are houses are damaged, they cannot go back to houses, right? This is the situation. So, what I am describing are actually impact of flood, right? What flood has done to these people. So, actually we are describing the impact of flood, and mostly impact can be both positive and negative, but I am mostly talking about impact that is negative, right, that is not benefiting people, harming people, right. Now, again you take a kind of thought experiment or another situation. Say there are 100 households in a village, the village, and the society of that village is kind of a, they have asked different kind of religions, different uh, communities, and technically they are diverse in their socio-economic status. Some are poor, some are middle class, lower middle class, some are rich, some are uneducated, some are educated, you know, etc., etc. So it's a highly heterogeneous kind of society. So you get lot of socio-economic elements which are not same, are different. When you think at the level of household, some households are richer, some are less rich, some are poor, some are more educated, some are less educated, some are well connected to the outside, what we call social networking, some are less, you know, some are so poor and so uneducated that they are very, very, very weak, which we call the weakest section of society. So it's a mixed kind of, and there is a flood. Do you think everybody or every household will be equally impacted? Even if inundation is same, 5 feet, the village is under 5 feet of water. Nature does not discriminate. Nature gives everything equally. If it gives flood, you will give same kind of flood to everybody. But do you think everybody will be equally impacted? No. Why? Why? This is important to understand, and that also can be mapped. Many people talk about impact mapping. उसका भी तरीका है. You tell me that everybody will be impacted equally? No. ठीक है, let me make it simple. There is a rich man whose house is damaged. There is a very poor man whose house is also damaged. Who will be more impacted? Huh? Poor people. Why? Then? Okay, they are already very what? You are already using the word. I thought that I would bring that word at the last of the session. Okay, that's fine, because basically because you think about impact. What can flood do to the rich man's house? It can destroy the ground floor. A rich man, he will live. He might be having 2-3 stories of a house, right? His ground floor can be affected, but he will live in very happily with his family in the first floor. He is a rich man, right? Or on the rooftop, right? So, he is getting relatively more flood proofed than the poor man. The poor man's entire house is gone. Either he has to leave that house, take shelter in some road, school or relief camp, or he has to live on a boat, otherwise he cannot survive. Since he is a poor man, his house must be constructed very weakly, isn't it? You can't expect him to have a very robust house. So, once it gets destroyed, it will not be easy for him to rebuild his house. In case of the rich man, it will be easier for him to rebuild his house. Since he is rich, he must be having some bank balance, right. So, it will be easier for him to recuperate, to recover from the shock of floods. The lesson learned is that if you are economically well off, you are less vulnerable. So, money matters, economy matters, financial position matters. That is one of the very important determinant of vulnerability. Not always. When there is a tsunami, your 3-story building is also gone. It is a different case, right. Then this one example. The other example is social status. Take the case of education and knowledge, right. You have a family that may not be very rich, very poor, middle class family, or maybe poor, still middle, still there are a couple of qualified educated people there, maybe a teacher and his wife and all that. They are not that rich, but they are knowledgeable, they are very informed, right. So, they actually know what to do, when to do, how to prepare before flood, during flood, after flood, how to maintain health and hygiene, right, or how to get the relief and rehabilitation, etc., etc. There may be a rich man who is very illiterate, he does not know actually. This family, although they are poorer, may be in an advantageous position because of their knowledge about so many things. So, sometimes knowledge as an important social attribute plays an important role in determining your vulnerability. These are only two examples, there are many, many others. Physical proximity or exposure is a very important determinant. If you are right on that hot spot, you are getting affected, you are making yourself more vulnerable, etc., etc. So, in a nutshell, I have told you about hazard, exposure, vulnerability. Then there are a few more terms, impact and risk. Risk is little bit complicated, so I will give you the definition later on, but let me tell you that what do you mean by risk anyway? Tell me again, what is risk? What is risk? We often say, no, do not take risk here. What does that mean? Huh? And there are most disaster management science is full of risk mapping right nowadays. And Arup will show you how we did some kind of a risk mapping in one village. Flood risk mapping, it can be anything, earthquake risk mapping, tsunami risk mapping, it can be landslide risk mapping, anything, social risk mapping, COVID risk mapping, a lot of COVID risk maps are there. Have you never taken any risk in life? Huh? Give me an example. That will clarify what you mean by risk. Uncertainty about the outcome, a little bit different. Risk is near certainty that there will be an unfavorable outcome, the knowledge that. there is a huge possibility, there is a probability, and risk is a probabilistic word. Actually, risk estimation calculation is a probabilistic exercise. So, you have to use statistics. Actually, it is little bit complicated. So, I am not giving that importance to risk, but it is so commonly used nowadays everywhere, everywhere. You talk about insurance, you talk about inflation, you talk about reserve bank reducing the repo rate everywhere, and COVID entire COVID is all about COVID risk. So, risk is a very important word, and each of these disciplines they acquire different meaning, but in disaster management they have a very specific meaning. It is probabilistic. The entire probability of an unfavorable outcome which grows out of the combination of your exposure, your vulnerability, your hazard, your impact, everything determining your near possible unfavorable outcome, right. The likelihood of an unfavorable situation which is latent, which is potent, right, in future. Risk is also little bit futuristic because it is probabilistic. So, essentially, not when I say this, I am not 100% technically correct, just to make you understand. When you say do not take risk, it means there is a risk waiting for you, but you can avoid that. It has not happened to you. It may happen to you if do certain things, right. So, risk is the likelihood of an unfavorable outcome to your system that is latent, that is potent, which can be enhanced, which can be increased, which can be avoided, which can be reduced, which can be lessened, right. So, that is the most general kind of meaning, but again I would like you to go through just for usko lao raha hai. Not easy to understand, but anyway, I said it takes time, but it is good that you are exposed to these definitions. You now know that there are standard definitions to follow. Definitions cannot be diluted, irrespective of whether we are comfortable with them or not. It may take time for you to understand, but it cannot be oversimplified or should not be oversimplified. Just to give you an example, it is the potential for adverse consequences for human or ecological systems, recognizing the diversity of values and objectives associated with such systems in the context of climate change. Risks can arise from potential impacts of climate change. This is with respect to climate change, but anyway it is relevant everywhere, as well as human responses to climate change. Relevant adverse consequences include those on lives, livelihood, health and well-being, economic, social and cultural assets and investments, infrastructure services, including ecosystem services, ecosystems and species. In the context of climate change impact, risk result from dynamic interactions between climate related hazards with the exposure and the vulnerability of the affected human or ecological systems to the hazards. So, it is a result of the interaction between hazard, exposure, vulnerability, right. If you put it in the, that is why I said climate risk, because that is what is very commonly discussed nowadays. Can be also disaster risk, equally true. So, in the context of climate change, the adverse effects of climate change, your exposure to these effects or hazards, and you are already vulnerable for various reasons, socio-economically, culturally, physically, whatever it is. The total, the near total, latent or potential situation that you are going to be, as a probability that you are going to be affected, right? Coming back to vulnerability. So, you know the vulnerability is the propensity or predisposition to be adversely affected. If that is latent in you, you acquire some characteristics physically, or your society is equipped with such habits, such characteristics that it will be affected. Then we call it affected by something that may be anything. It can be a hazard like flood, it can be uh, you know civil riots, communal riots. These are all important examples of hazards. Civic unrest, law and order situation, fire, these are all important stretches, or these are all important hazards that have the potential to affect you if you are vulnerable. So, vulnerability encompasses a variety of concepts and elements, including sensitivity or susceptibility to harm and lack of capacity of cope and adapt. So, additionally, what it means that if you are vulnerable, it means you are susceptible or sensitive to something, at the same time you have lack of capacity or to cope and adapt. So, it is, as I said, it is a very, very meaningful word, and that is why many people call it vulnerability science also. Anyway, the other word, impact, and I think that will be the last word as far as these concepts are concerned. The consequences of realized risks or natural or human systems where risks result from the interaction of climate related hazards or any hazard, including extreme weather, climate events, exposure and vulnerability. The consequences of realized risk, that means impact is something that has already happened. Got? All those people who are living in shelter camps, who have become homeless, right, who have become poorer, right, who will, some of them probably can never rise up to the level after the floods. They will remain poor throughout their life, right. These are impacts. And till that happened in real life, those were risks. So, risks are probable impacts waiting to happen. To be very simple and straightforward, right. My first part is over, right. How much time is left? For tea? Okay, no problem. I also need a cup of tea, right. So, as I warned you, the first part was little bit, I did not say that it is going to be easy. Most of the terms and their meanings were new to you, am I right? Or you already knew that? How many of them already knew all these scientific meanings? Not a single one. So, I suppose that they were new to you, right? It is important to learn new things. They will not appear easy for you. I suggest whenever you have time, if you are interested to pursue something in disaster management, you keep on exploring, keep on familiarizing with these words, with these terms, and you will soon become, very conversant, very comfortable with these terms. And in my next part of presentation, we will see how we will examine some maps, that is all, where these concepts have been represented, and we will see the merits and demerits, right. Ah, you can go please for your tea. बिना चीनी हाँ Questions? Or you are all silence loving people? So, as I said, this part is all about maps. Now, you tell me in the last 1 week, what have you learned about geospatial technology and its application? Just give me an idea, because I was not present last week. क्या सीखा 3 लोगों ने? बस एक 2 मिनट में बता दो मुझे, क्या क्या सिखाया गया? वो 2 चीज़ अलग है ना. What you learned and what was taught to you is 2 different questions. Lot of things may be taught to you, you may not learn anything, right? So क्या सिखाया गया यही बताओ. What was taught to you in last 1 week? Give me some examples. ये बताया वो बताया.
Sir, we were taught about GIS, remote sensing, map projection, and as well how to make map in ArcGIS, Ardos GIS, and NV. We were taught about NV too, but we didn't do it practically. So in this 6 days, I have learned about GIS. They taught about how to take maps from Bhuvan, as well from Art Explorer, Survey of India, as well they taught us about the theoretical part of GIS,
Okay.
as well remote sensing too.
Good, good. So, and then how many of you already have the knowledge of geospatial technology, means GIS, remote sensing? You have. Anybody else? Only one person who is already knowledgeable. You have some exposure. Okay. Okay. So I'm again using the same word. You already had some exposure to GIS, right? Right? Okay, good. So this time I am using this word in a very positive context, right? So you might have understood that a lot of geospatial technology application is about preparing maps. Not 100% of it, but a large part of things, then activities that you do, or purpose, objective of applying geospatial technology is to create and prepare different types of maps. Because why are maps useful? Why are maps needed? Why do we give so much of importance to maps? Why do we create maps? Because maps can convey you a lot of information in a small space, especially information that is spatially distributed, right? Any information which is variable over space geographically can be presented or represented in maps. A lot of information, very rich amount of information can be put into a map, and that is the utility of maps, right? In earlier days we used to have this beautiful art called cartography. You know cartography? What is cartography?
Looking in flat surface or
Yeah.
a seat.
Yeah. Now we call it digital cartography because we no longer do it manually. We use lot of what? Again, lot of software, apps, CAD, CAMs, GIS, right? So from the good old days of cartography till the days of digital cartography, so much of advancement has happened, but what has happened that the utility of maps is actually increasing. Now we can create much better maps which can give you even much more information than you could give in the past, and in very different way. Now a lot of 3D maps which gives you the other dimension also, right, and very different kind of maps. In this session I will show you some maps which is related to representation of different kind of disaster situations or hazard situations, where we will be using these 4 or 5 key terms that we have learned in the first session. So, what lies in front of you is called a flood hazard map, right. So, these I have not created these maps, these are from standard sources, these are from Government of Assam State Disaster Management Authority. They are using these maps. We will analyze some aspects of these maps. Now, why do we call it flood? Sometimes some people alternatively also use the word flood map. There can be different things. That is what I am trying to make you understand. Flood maps are almost equal to flood hazard maps. Hazard means the event, the distress, the stress. The event is flooding. Flooding is a physical event, isn't it? It's a natural phenomenon, right? The water in a river spills over in the rainy season. When it gets a lot of rain, it can't carry all the runoff from the upstream to downstream, so it spills over, and when it's too much of spilling, it results in inundation on both the banks, and that's flooding, right. So, actually a flood hazard map represents the area of inundation, the area that is inundated, submerged. It can also represent the area that has been affected. Sometimes the area inundated may or may not be equal to the area affected. Area of inundation may be less, area affected may be high, depending on how you measure the effects of flooding, right. And when you use remote sensing, use satellite data, it also depends on the type of satellite data that you are using, whether that satellite or the sensors used in satellite is capable of capturing the actual ground inundation or not, to what extent, right, the factors. So, what you see here is called a flood hazard map. Mostly you see it is an inundation map. I think it is an inundation map. I mean, these are the areas which are inundated, and therefore the hazard is more in some areas, the hazard is less in some areas. So, you know how to, you are familiar with reading a map, right. Map reading is very easy, isn't it? You have to look at the legends. Huh? Now, you tell me, looking at this map, what does this thick blue line mean? Huh? Which river? Brahmaputra. Okay, is Brahmaputra the only river in Assam? There are other rivers also, which you rarely see. There are some big ones. Okay, anyway, now you tell me which are the areas where flood hazard is maximum. You can see the maps from there, na? If I ask you, how will you know where it is maximum, where it is minimum? By looking at the legends, isn't it? That is not enough. You have to actually put your mind. It is good, But now think about the very high is less than dark brown, isn't it? Which are the dark brown areas? You see, which are mostly located on the bank of the river Brahmaputra, right? And some other areas also, Borak. What I am trying to do is I am trying to, I have some experience about floods in Assam, so I am trying to see whether it matches my experience or my knowledge or not, right? And based on that, I will say that it is correct, it is not correct, or it needs improvement. That is first thing. And the second thing is that if I ask you, now you know what a hazard and all that. If I ask you, if I give you an assignment of how you will prepare a flood hazard map of Guwahati or this area or your home constituency or your city, what will be your approach? That is important to know. The details will be, if you ask, the details can be given by Arup, but I am just curious to know what will be your approach, right? Now, this is a flood hazard map, and the purpose of preparing this map is to give you an idea of geographical distribution of intensity of flood hazard. So, you see that everywhere flood hazard is not same. In some areas it is more, in some areas it is less. Why? Because in some areas inundation is more. There are different reasons. Big river Brahmaputra, there are some small rivers, small inundation. There are some upland where there is less flood or no flood, where some low lying area there is more flood. So, depending on various geographical circumstances, topography, landscape characteristics, you have different kind of flooding. And what is the utility of these maps? What is the importance of this map? Why do you need this kind of map? ठीक है, हमने बना तो लिया इस मैप को, लेकिन क्यों चाहिए ये मैप? Number one, see, this map is not prepared data of 1 year. This map is prepared with data of many years. So, you get an average, long term average flood situation, you get just in one map. And it also tells you that everywhere it is not same. In some places it is more, some places medium, in some places it is low. So, it gives the information to the decision makers that these are the places where you should give more attention. You should do more flood relief, you should give more flood relief, you should do more flood preparedness, you should give more importance to the areas, because these are areas that have been suffering more flood hazards than others. So, that gives you a tool to make better decisions, right. Otherwise, the flood water resource minister may ask you, where should we concentrate our efforts in? We can't work equally all over the state. Where should we do more work? Where should we do less work? So, these are the areas, all the dark brown areas. So, you are actually helping the decision maker in taking good decisions for flood management. That is one utility of these maps, right. And knowledge wise also, this gives you a spatial pattern, the geographical pattern of flooding. You know that there are some areas which are flood free. There is hardly any flood free area nowadays except in Assam, except for the two hill districts. I will show you later on, but still you know that these are relatively so these are relatively flood free areas and all that. So, if there is an industry, a big industry which wants to come to Assam and wants a flood free zone and a flood secured place where it will not be affected by floods, you have the information where you have actually flood free zones. Huh? Isn't that useful? So, that is the usefulness of maps. Huh? And remember, this is flood hazard. So, it is mostly either flood inundation or flood effect, means impact, right. We do not know because we do not know the methodology through which, but we can discuss about it later on. This is different. This is a vulnerability map, right. This is a vulnerability map. This is not a hazard map, right. And this is actually, this is a vulnerability map for entire Northeast India including Sikkim. It was prepared by the International Center for Integrated Mountain Development quite ago, almost 10-12 years back. It was a good example. So, this map represents vulnerability to climate change, right, or in a very approximately you can also call as climate risk. Here if I want to read the map, what they have done actually, they have classified the entire northeast area into according to some vulnerability indices. So, they have ascribed vulnerability, they have estimated vulnerability index for different areas, then they have clustered. So, estimation of vulnerability index, clustering, these are different techniques that you use in GIS, applying GIS for producing this kind of maps. So, here you see the brown color shows you the areas with maximum vulnerability. And what are these brown color areas you see? See the Assam part? What is this area? You just saw it in the previous map, na? What is that? Huh? Speak loudly. So, you are not confident. Huh? See, map reading is a very important skill that you must acquire actually. Yeah, it's Brahmaputra. That's why it starts here, isn't it? It starts here and goes up to this. This part they are not covering. This is Bangladesh, right? This is the main Brahmaputra. The other way Siang and all that. So, in Assam, both banks of Brahmaputra and certain area are very vulnerable to climate change, mainly flooding. Flood erosion, there are many other water induced disasters, but mainly flooding. So, please remember, this is a vulnerability map. Here it does not show impact or hazard or inundation, it shows people mainly human beings and natural ecosystems living in these areas are highly vulnerable. Why they are vulnerable? There may be many factors. First is that they are living close to a big river which is very flood prone. The entire area is flood prone, so their exposure is high. The natural hazard is already there, annual flooding. Their exposure is high, they live in that area. They are highly vulnerable because in most cases the general socio-economic character is that they are either people living below poverty line or marginally above poverty line. Then they may not be that educated, socially enriched, well connected, right? Literacy rate may be low, right? Sex ratio may be low, and then what you call infant mortality may be high, right? All these development parameters you apply, you will see they are low. That means the mortality rate may be high, part rate may be high. So many things are combining together to make them vulnerable. It is not only about their location on the bank of the Brahmaputra. So many things, mainly poverty, dependence on their main livelihood is agriculture, and agriculture is highly affected by climate change. Agriculture, horticulture, pisciculture, dairy, all these farm based livelihoods are highly affected by climate change. So, if your main livelihood belongs to one of them, you are highly vulnerable to climate change. So, so many factors combine to determine your vulnerability, and in that sense the vulnerability is very high. It is different from a hazard map, right? Okay. I don't need this, nothing. Okay. I am not going to repeat anything, but I just want to tell you that I assume that you know about climate change, you know what is climate change, what is global warming, you know what are the various impacts of climate change. It is general knowledge. I have just added one word called risk, that is all. So, it is all about impact of climate change, but risk technically it is little bit futuristic, that is all, right. So, I have covered this actually. Just to give you an idea, I am showing this slide because just to give you an idea, there is not even a single aspect of our lives which is not affected by climate change. Everything around us. That is why it is the most concerning issue for the entire humanity and for the entire world, and therefore all the world leaders, the United Nations, they are giving maximum importance for resolving this crisis. For example, agriculture, food security, the basic aspects of our life without which we cannot survive, sustain or progress, our civilization will stop. Agriculture or any source of food security, our flora, fauna, biodiversity, our habitats, ecosystems, our health and nutrition, waters, our river, wetlands, all natural resources, our society, our culture, our different kind of natural disasters, everything, all development goals, all SDGs, sustainable development goals. You are familiar with this word? Unfortunately, I have no time to elaborate on this. If you are new to this word, please search in internet, you will get sustainable development goals. There are 17 goals which the United Nations have constructed or envisaged to be achieved. They were adopted in 2015 with a timeline of 15 years. By 2030 they are supposed to be achieved by each and every country, and these are the best parameters for sustainable development nowadays. So, you will see when you read all these 17 parameters are affected by climate change, right. So, if you want to estimate, measure, assess sustainable development, you have to you have to know about these sustainable development goals, and accordingly there are goals and then and there are different indicators also. So, this will add to your general knowledge or professional knowledge, whatever you call it. So, this I am showing you that to give you the idea of a basin. You know what is a basin? River basin. If time permits, Saurabh will tell you why it is important to. you know, we know about, because one important application of geospatial technology is to create, to delineate or cut out the catchment area or basin of a river, which is very, very useful. And river basins are the best natural units for development planning. If you are a student of geography, you know that. For geographical planning of any country, any state, any city, river catchments or basins are the best natural units. So, it is important to know what a basin is, what a catchment area is, right. And then there is a way to create basin maps using remote sensing and GIS, which is very important. Say for the Brahmaputra, this is one of those, there are many maps are available, one of those maps. So, basin is generally defined as the area from which all the rainfall getting converted into runoff ultimately comes to the channel of that river, and the channel, when it flows out of the basin, is supposed to carry all the runoff. Every raindrop that falls in this area, every raindrop will directly or indirectly contribute to the flow of the Brahmaputra. That is the concept of a basin. Ekdam simple, ekdam simple. All the rainfall will get converted to runoff and will gather ultimately, and the rain and runoff will come to this main Brahmaputra through different tributaries, right. So, tributaries are not enough. Tributaries have their own tributaries, their tributaries have smaller tributaries, their tributaries have smaller tributaries. So, if possible, give them a kind of, the first order, second order, third order streams. How we map them, this is also used to be a good work of cartographers, but now we have software to do that, where ArcGIS or wherever you can do that actually there are, right. But you have to do. So, I give it importance both because we do a lot of, in RNF we do a lot of catchment delineation, which is very important, not only of rivers but also wetlands. They are natural units. If you want to have a plan, conservation plan for a wetland, you have to know the area that lies in its catchment, right. So, therefore, I am showing this map. This map, part of this map lies in Tibet, China, because the origin of the Brahmaputra lies in Tibet, China. From that point onwards, the Brahmaputra flows like this, then enters India, flows through Assam and goes to Bangladesh, and finally flows down to Bay of Bengal. The entire region is covered, right. So, to get a fuller understanding of water induced disasters, flood, cyclone, tsunami or whatever it is, you need to have the idea of the basin, and you need to know where from this flood is coming. In many circumstances, say in last 1 month, in the month of June, some of you might have seen news in the TV channels or might have read news in newspapers or in social media that lot of people are saying that water coming from Bhutan is actually responsible for flooding the western part of Assam. Have you heard about that? Water coming from Bhutan, either from dams or from other rivers, right. So, this means this flood in a way, in some circumstances, was not produced in Assam, it was produced in Bhutan. But finally, the flood water flows to Assam, because all these rivers are tributaries to Brahmaputra, they come and meet the Brahmaputra. So, on the way it floods. So, you should know actually, if you have a basin idea, basin level idea, then it helps you to know the nature of flooding, right. And it helps you to understand the whole gamut of impact and vulnerability. right. This is another map I usually show. Anybody from geology, civil engineering, geography? A lot. So, you should be able to tell me what this is. For others also, these are simple maps. Huh? You do not have to be very afraid of them. It's very simple maps. But map is not text. It is not WhatsApp. In 2 minutes, you will not understand anything. You have to attend. You have to carefully read it. That is called map reading. Then only, because I said map, why maps are useful, because it conveys a lot of message. अरे तुमको पढ़ना तो पड़ेगा ना, then only you get the message. Map reading is not like reading a text message, na. You have to concentrate, you have to apply your brain, mind, then only you will understand what is there. So थोड़ा बारीकी से देखो, you will understand, right? For those who have a kind of geology, kind of they may be already familiar. What you can see is that essentially for everybody, sorry, what you can see is that these are all hills and mountains, right? Go to Google Map, see the map of Northeast India, see the map of Himalayas, see the map of the entire Northeast India, Assam. You can differentiate just by seeing what is hill, what is plain, what is hill, what is valley, what is plain. You can understand, right? Nobody will teach you all these small things. You have to learn yourself. And you see, these are mountainous or hilly areas. In between again you have mountainous hilly areas. The green areas are flat areas. And this is where, doesn't it look like the map of Assam? So this is where Assam is located, right? This is Meghalaya. So mostly the Brahmaputra valley, this is flat. So this map tells you very clearly that we live in an area which is surrounded by high hills, right? Right? It means all the rainfall that falls on these hills will definitely come down to the valley, right? And to this situation add your knowledge that we live in a very rainy area. Entire Northeast receives a lot of rainfall. Yeah? A lot of rainfall is experienced by these hills and mountains, and most of it rushes down to the valley. That is the basic of flooding. Where will the water go? This is part of the natural hydrological cycle. You cannot break this cycle. You cannot go against nature. Somehow the water has to go somewhere, na? After it comes as a rainfall, it gets converted into surface runoff, mostly after some amount of infiltration and percolation to groundwater and subsurface water. Most of it is runoff, and they find their ways through small first order, second order, third order tributaries to the larger tributaries, and ultimately to the Brahmaputra. And on the way, if there is more rainfall, flooding, all the water comes and accumulates in the. So just by looking at this map, you can explain why it floods in Assam. Many people ask, इतना बार क्यों होता है असम? My answer is that असम में नहीं होता, कहाँ होगा यार? ऐसा बनाया गया है असम को. Assam we are destined to face floods. We are destined. होना ही है. This story is best told by a map, right? Additionally, this map also gives you the fault lines, geological fault lines. right. This is a different meaning. I will not complicate things right now. Not. Now see this. Simple Google map. Simple Google map. Again Assam. Here you see the full Brahmaputra, right? Ekdam from Tibet, Yarlung Jangpo Sampo comes, Arunachal, from Arunachal Siang comes there, Lohit comes, Dibang comes, Brahmaputra, and then finally up to. In the entire green background, you see a grey patch, continuous grey patch. What is that? Huh? Loudly, loudly. Entire grey patches, not Brahmaputra. The main grey line is Brahmaputra, that is fine. Then what is the entire grey patch? Huh? Huh? Loudly, loudly, confidently. You may be wrong. Oh, no. Huh? Flood area. Exactly. These are plains. See, you and me are not creating Google Earth, really. A simple Google Earth gives you the entire map of Brahmaputra Valley. You just take a pencil and cut out draw the outline, cut it out. You get the Brahmaputra Valley, the Brahmaputra plains. And in a similar way also the Barak plain, but which is not very prominent here anyway for various reasons, but you get it. I do not know, Arup can tell me whether it is naturally like this or somebody has processed it, Arup, I do not know, but I really like this actually. Simple Google Earth gives you a very good idea of the Brahmaputra Valley, where there is hill, where there is plain. And I think on Google Earth you can do some processing also, I am not sure about also, and you can do things like that, but I found it really useful, because the context of this lecture I am giving you is Brahmaputra Valley. I am not talking about Barak or other places. So see, again, you can do certain things using remote sensing GIS, you can improve this further. You can put an outline also, you will get it in the Pura. This is the Brahmaputra, which some valley or something like that, but you see, this is so important. This is why I say the Assam is destined to get floods. Another map which shows it beautifully. What do you see in this map? Let me know. फूस के मत बताओ, एकदम सीधा बताओ. हाँ, loudly.
Some tributaries joining the Brahmaputra river.
ठीक है. Anybody else? What does this map mean to you? That's it. There are so many streams or rivers. Stream is a word that we usually use for small rivers or rivulets, right? Otherwise bigger ones we call rivers, not streams. So there are so many rivers. How many rivers? How many rivers? You can actually count. So in Assam, there are about 145 major rivers, right? Except for the main two rivers, Brahmaputra and Barak. They are main tributaries total, so many. And if you add to them all the small rivers, then you see only rivers and rivers and rivers, and that is why Assam is called the land of rivers, where actually area occupied by river is more than area occupied by land. You feel this situation during flood. When you see a flood map, you will see entire Assam is underwater, except for this hill districts, West Karbi Anglong, East Karbi Anglong and Dima Hasao, and part of Kachar, some hilly areas, almost 70 to 80% of the state is affected, right. So, this we usually call drainage map or river density map or river map. Anyway, this is also acquired from satellite. Somehow I forgot to show you a cartographic map of, somehow it did not come actually, cartographic map of rivers, which is much better actually, but nowadays nobody does that. So, you will have to do it like this only. Similarly, if you belong to a particular district, you can try a drainage map of that district, your own district, and see, you go to you use such method which gives you the thinnest line also as a river, then only you will be more accurate, because in this kind of map almost I can say that about 15 to 20% rivers are not coming at all, the small ones, but big scale maps, etc. So, I am not giving you anything except just to give you a sense of, we are talking about water induced disasters, there are many, but we are taking flood as the main one, because flood and erosion the main water induced disasters, and we have potential opportunities for applying remote sensing GIS to study both these phenomena, flood and erosion. Now, we all say that oh, Assam is so flood prone, means Assam is so highly flood affected, in the past, in the present, will remain so in the future, right. How much? In science you have to be quantitative rather than qualitative. Oh, so much of flood, how much? So many rivers, how many? Right? These are answers you have to give in science, if you want to do something in science. So, I am just giving you some statistics just for your information, and all these statistics can be represented in maps. In future, when you learn more about, I do not have time, neither Urup has that much of time, I am giving you that, I am showing you the potential that when you learn more and more about geospatial, when you become experts in geospatial and all that, so that you can apply your knowledge to mapping of all aspects of flooding. Give me 1 minute. Out of that I will read only one. Assam has the largest flood prone area in the country. It is 3.1 million hectare. 3.1 million hectare. Can you convert it into square kilometer? 31,000 square kilometer, by the way. Anyway, which is 40% of the state's geographical area. Assam's geographical area is about 78,000 square kilometer. Out of that, 40% is flood prone, right, which is equal to 9.6% of the country's total flood prone area. Assam's 40% and country's 10%, which is huge, isn't it? But why I am showing this information to you is, has a different reason. This is an estimate that was made by the Rashtriya Bar Ayog or National Flood Commission back in 1980, 4 decades before. After 4 decades, right, if you look back at the flood history of Assam, it has suffered from about 20 major floods in last 70 years, and more than 10 have occurred after 80. So, the flood history after 1980 is very important. Through our ground experience, through our observation, through our research and documentation, we know that in the last 40 years many new areas have come under the grip of flooding in Assam. Many new areas which were never flooded are now regularly flooded, like it is happening in Guwahati, like it is happening in Silchar, everywhere. This year also you must have heard that ইয়াতটো কেতিয়াও ফ্লাড হোৱা নাছিল, এইটো ফৰ দ্য ফাৰ্ষ্ট টাইম আমি জীৱনত প্ৰথম দেখিছোঁ ফ্লাড হৈছে, ফৰ দ্য ফাৰ্ষ্ট টাইম উই হেভ seen that this area is flooded. So these are all important information. So what do you expect after 40 years the flood prone area should increase or decrease? Loudly increase. That's a logical conclusion, right? If you go back to the data of ASDMA this year, they will tell you that okay, out of 36 districts of Assam, 32 are under water. So much of area is under water. Almost 60% area is under water. Things like that. 50% area is under water. More than 5,000 villages is affected, etc. But what has happened in between is that in 2011 there was an estimation by NRSC, National Remote Sensing Center, ISRO, and they and 2016, and they prepared upgraded flood hazard map of Assam, where they found that they said that 22% of geographical area of Assam is affected by flood. Rashtriya Bar Ayog estimated as 40%. We expect that after 4 decades it should be at least 50%, right? ISRO NRSC says it is 22%. I do not believe in this figure, neither should you. Need to be questioned. Just because NRSC or ISRO does it, it's not that they are above questioning. This is beyond common understanding. So, although I have raised this issue, there is no plausible answer. This means there are 2-3 things. This is not the only case where you have seen remote sensing GIS has been applied by the experts and they have come out with results which does not match reality, right? Why? Because remote sensing GIS are very important tools, but the accuracy of the result you produce depends on your expertise, right? Am I right? Right? It is not enough to apply the most sophisticated techniques of satellite meteorology or satellite technology. Your field validation of your result is very important. Information, field level information, high resolution field level information through very intensive and comprehensive field work is very important. Then only your results will become closer to reality. Otherwise, this is the thing you will keep on getting, right? So, this is an example also where we see that this does not match with reality. It may be because of a particular methodology they have adopted, right? It may be because of something else. Maybe in 2015 they were not able to use SAR data, probably there were no Sentinel available. Now if they redo it, probably they will revise their, but in between the result we have may not be correct, right? This is one. In the meantime, the same figure for India, how much of India's landmass is prone to flood. As per Rashtriya Bar Ayog in 1980 it was 12%. It was re-estimated again in 2011, it was found that it has increased to 15%, which is true. In case of an all India estimation it has increased, but for Assam it has been drastically decreased by 18%, which probably is not correct. Let me give you the last example and then wind up. Okay, in between, this is an example of, I told you this is exposure. Exposure is a very important parameter. This is a map which shows you the expected average annual population exposed to flood hazard. This is very important map, and maybe in your practical class, if Arup can stay back, I may not be able to. Otherwise, we could have discussed about how to prepare this kind of a map. So, these maps give you again in terms of lesions different zones where you have different population exposed to flood, right. The red ones are the most dangerous ones, most important ones, where more than 2,10,000 people are exposed at least to flood. This is a very important map. Before preparing the vulnerability map, you have to prepare this map, because and first you have to prepare the flood hazard map, then exposure map, then you do a comprehensive field survey for assessment of vulnerability, then you can prepare the vulnerability map. It is not that easy. So, you should always start with a small village just to learn the procedure, small village or ward or a small place, so that you can handle that kind of data, otherwise not. So, my last example is this is the flood map of or flood hazard map, which shows villages or wards or whatever it is, areas under high flood or very high flood. So, red means high and very high flood zones. The reason I am showing you this map is for Kachar. During the last flood in the month of June, if you remember, which place in entire Assam suffered most from floods? Loudly, huh? In June, not Dima Hasao. Dima Hasao was in, huh? Huh? Silchar, the most affected area was Silchar. In this map of Kasad, this is Silchar, its legend is this: you do not see even a single red spot in Silchar. According to this map, Silchar is not that vulnerable to flood, or Silchar is not highly affected by flood. But in 2022, Silchar was the most affected flood area. This map is wrong as of today. It might have been right in 2015 when it was published. So, the point I am raising is that situation changes. So, you have to keep on changing your maps. Flood hazard keeps on changing, your exposure keeps on changing, your vulnerability keeps on changing. So, you have to keep on updating your maps, that is very important. What was valid in 2015, the year of publication of this map, does not hold true today. Today's situation is different. Today, if you draw a flood hazard map for Kachar, it would look completely different. So, that is the point I wanted to make actually. These in water induced hazards, taking flood as an example, right. Uh, these concepts are very important: hazard, impact, vulnerability, risk. I did not have time to talk about impact mapping and risk mapping. Arup will show you a kind of risk maps that we had prepared. We have other examples which Arup will show you. I think I gave you just a very basic introduction to the concept, the idea, and wanted to tell you where geospatial technology can be used to represent those ideas or to explain things that you see on ground. So, thank you very much. I always take more time than I am given, so I do not regret for that, as long as it is useful to you, right. So, I will be here. So, Arup will be presenting. And whenever I have an opportunity, I will also add to his presentation just to make things clear to you, right. Arup, তুমি এইটো ল'ব লাগিব. Somebody will call Bipul. এইখিনি লগাই দে না.
educational qualification and from which place you are from. So, just your name and the state or district and your subject.
Good afternoon, sir. I'm Anjan Mosor from West Khasil, Meghalaya.
Okay. And subject, what we have
I'm
studied?
studying geography.
Geography?
Yes, sir.
From Nehu?
No, yes, from Nehu, but I university in William Carey.
Okay, thank you.
Okay, sir.
Next.
Hello, my name is Nikita. I'm from Assam, and I completed my masters in GIS from Bangalore University.
Okay.
Hello, I am Pooja Talukdar. I am from Guwahati. I have done my masters in geography from Cotton University.
My name is Kiwi Bori. I'm from Arunachal Pradesh, Isyang district, Pasigat, and I have done my master degree from William Carey in geography.
Okay. So we are from same place. So I did my schooling from class 4 to say till graduation from the same place. That place is called Pasigat in Arunachal Pradesh. Okay. I also studied in Jain College. Next.
Good evening, sir. My name is Senam Padung, and I am from Arunachal Pradesh, Upper Siang district, Tuting.
Tuting. Okay.
I completed my master degree in William Carey University, Shillong.
Okay.
Thank you.
Good afternoon, sir. My name is Longbak Parame from Meghalaya. So now I'm doing my MA in William Carey University, Geography.
Afternoon, sir. Myself, Steven Sandakar, and I'm doing my MA in Geography in Meghalaya, that's in Shillong, in William Carey University.
Okay.
Good afternoon, sir. Myself, Laithama Basumatari. I'm original belong from Karbi Anglong district. I have passed out my masters from Assam University, and I'm now presently pursuing PhD in USTM, University of Science and Technology, Meghalaya.
In which subject?
Sir, in Department of Geography.
Okay.
So, good afternoon, sir. My name is Super Strong, and I'm from West Chaitia Hills District, Meghalaya. I've completed my BTech in Civil Engineering from Regional Institute of Science and Technology, Meghalaya.
Good afternoon, sir. My name is Tina Lapang, and I'm from Meghalaya Ribhoi District. I've done my graduation in BTech Civil from Regional Institute of Science and Technology.
Good afternoon, sir. My name is Sanam Redman. I'm from Shillong. I study my master in William Carey University in Shillong.
Subject?
Geography.
Okay.
Good evening, sir. My name is Barbie M. Sangma, and I'm pursuing my master degree in geography in William Carey University, and I'm from Tura, Meghalaya, West Karo Hills.
Good afternoon, sir. My name is Eureka, and I passed out my degree from Synod College, Shillong.
Good evening, sir. I'm Barihun Almonai. I'm from Shillong. I completed my degree, BSc Geography.
Good afternoon, sir. My name is Dajuk Lin Nonglang from Shillong, and I did my master degree in William Carey, Department Geography.
Geography. Okay, thank you. So it seems most of the participants are from geography, and say the syllabus in degree level actually have some papers on remote sensing and GIS. Okay. So Okay, so studying water induced disaster and climate risk in the Brahmaputra Valley. So, I will show you some of the mapping tasks we have done, as well as some field works. So, if you see this picture, this is mainly the participatory GIS, PGIS. Okay. So, simply looking at the satellite image is not so important. Important is we have to understand the ground informations as well as the local people of any affected area. Okay. They only, based on their perception, they only know the area, their own area, what was there, what are the features. So, this is called participatory GIS, means involving local community or local people. Okay. So, you have to provide means okay.
This one is for forward, this is for back.
Okay, and for this. So, participatory GIS is very much important. So, local people they draw the features, okay, in their surrounding areas. So, with the help of this picture or the sketch map, we can transform into GIS platform. Okay. So, I hope all of you know about the sources of data. Data कहाँ से मिलता है? So, to study say flood or bank line or forest cover change, we need data. So, what are the two data types in GIS? Anyone? Please raise your hand. इसमें डरने का बात नहीं है.
Speak loudly, confidently.
Yes.
Vector data.
Raster and vector. Okay. So, correct. So, from which year onwards we are getting the satellite images? This is also an important question. Suppose we want to do some study, but we are not familiar that from which year we are generally getting the satellite image, or the images are available from which year and what type of satellite images. These are some of the basic questions we have to understand before actually doing the work. Okay. किस तरह का हमें डेटा चाहिए? डायरेक्टली काम नहीं करना है, उससे पहले हमें समझना पड़ेगा कि हमें किस तरह का डेटा चाहिए. So, raster and vector is there. These words are very new for some of the students mainly. Okay. ये सब words जो है general words नहीं है. When I was in masters, okay, मैंने भी cotton से पढ़ा है from geography department, from your department. So हमारे सर raster vector बोलते रहते थे, तो हमें समझ में नहीं आता है. So समझने के लिए 6 महीने लग गए. What is the difference between raster and vector? So a simple example I will show you, or I will give you. Say during our school days, mostly the girls students, they prepare some SUPW or extracurricular activities. They stitch some flowers on clothes, no? Okay? Say rose with some leaves. वो flower आप कहाँ से लेते हैं? From the sari of your mother or some bed sheets, उसमें tracing paper रख के आप draw करते हैं. Correct? Yes or no? Yes. So the source, that is the sari, if we relate this, we can say this as raster. Raster. Okay. Pencil like a tool, this like a tool we have prepared one layer, say one rows, one layer, okay. तो दूसरा sheet लगाया, हम और कुछ दूसरा बनाया. So these are individual layers. We call these as say vector, okay. Anything or as per our requirement, if we extract the data, okay, with the help of some tools from satellite images or raster data in the form of say point line polygon, okay, हम उसको vector भी बोल सकते हैं. कुछ भी चीज, any features on the surface of the earth, say Guwahati GMC area, you have to suppose if we give you some assignment, some project, say you have to prepare a map of Guwahati city showing the important dustbin locations. So for that you need the boundary, yes or not? Yes. So boundary is closed or open? City boundary is closed or open? Closed. Then only you will get the area, no? Okay. So we need one polygon, that is the boundary. Then the important roads, that is in line. So one is polygon, one is line. And suppose if we do some field work using GPS, and if we collect the dustbin locations in the form of latitude and longitude, say points, with some additional say information, means the attribute. So we are getting the point, line and polygon, and these are vector or raster? Yes, vector or not? Vector or raster? ये समझ में नहीं आने से it is not possible to go forward, okay. Okay, in other words, all the satellite images, Survey of India topo sheets, I think most of the geography students, they use topo sheets in say practicals, yes or not? So satellite images, Survey of India topo sheet, okay. Say suppose one village is there, and suppose we do not have any satellite images or topo sheets, but the village people, they sketch their own area. So this is one sketch map. If we scan this, this will also be converted as raster. So satellite image, topo sheet, sketch map, these are considered as raster, but the pixel size are different. Suppose raster is there, and with the help of some tool, if we digitize or delineate or draw, these are synonyms, okay. कभी कभी बोलते हैं कि delineation क्या है, कभी बोलते हैं कि digitize करना है, okay. So these are the terms generally we use in GIS, and we extract the layer in the form of say point, line and polygon. So इसको हम बोलते हैं वेक्टर. और एट्रीब्यूट्स क्या है? सपोज एक पॉइंट है डस्टबिन, वो डस्टबिन उस एरिया में कब से, कौन से ईयर से था, से 2014. सो एक कॉलम होगा, एडिशनल इंफॉर्मेशन. दीज आर कॉल्ड, these columns are additional informations, or we can call it as attributes. और कितने, उस वार्ड का नाम क्या है, वो जो डस्टबिन जो वार्ड में है, say ward number 17, this is also an additional information. We consider this as attributes, okay. ठीक है. So from which year we are getting the satellite images? I think this part is covered, I think, okay. Okay, so every day if we Okay, please listen. One website is there called Earth Explorer. Yes or not? Okay. So earlier, if we need any satellite image, we have to approach. अगर आपको satellite image चाहिए, आप कहाँ जाएगा, किसके पास? I'll come to the mapping part later, but we have to understand these fundamental things. Suppose you are doing some projects, okay, and you have to apply remote sensing and GIS. For that you need satellite image, okay. So whom to approach to get the satellite image? पहले क्या होता था, freely available satellite image हमें ज़्यादा नहीं मिलता था, okay, clear? So India में NRSC, पहले NRSA बोलता था, agency, National Remote Sensing Agency, that is in Balanagar, Hyderabad, that is the ISRO center. Nowadays it is renamed as NRSC, National Remote Sensing Center. So NRSC is the only nodal agency which disseminate or provide the IRS as well as the foreign satellite images. IRS means Indian Remote Sensing Satellite Data, okay. So most of the scientists of ISRO, they actually work there. Likewise IIRS, Indian Institute of Remote Sensing, that is in Dehradun. So if you want to do, after this training, if you want to do some higher studies in remote sensing, you can apply in IIRS, Indian Institute of Remote Sensing, okay. Some courses are there, say PG diploma in various fields, then PhD is also there, MSc is also there, okay. Anyway, so we are getting the satellite images from nowadays from Earth Explorer. So earlier, from which year? From 1972 onwards. So एक period है, लिखा हुआ है from 1972 to 1992. But if we search for Assam, the earlier images, that is called MSS, Landsat MSS. क्या लिखना है आपको? Landsat MSS. इसका जो टाइम पीरियड है फ्रॉम 1972, असम में हमको लगभग 1978 तक का, उस बीच में आपको सैटेलाइट इमेज मिलता है. ये नहीं है कि 1972 में ही मिलेगा, या तो 73 में मिला लेकिन क्लाउड एरिया है, ओके. सो द बेस्ट पॉसिबल सैटेलाइट इमेज यू हैव टू सर्च, से 1974 में हमको मिला, ओके. देन उसके बाद Landsat TM 1988 to 2010 तक मिलता है, उस रेंज में. If you need the satellite image of any area for 1991, then you have to go for Landsat TM, okay. Okay. Then plus ETM, Enhanced Thematic Mapper. Generally we are getting from 1998 till 2010, but from 2004 onwards the image quality is not good, some parallel line, some problems are there, okay. So generally up to 2002 we are getting the good images, okay. ये थोड़ा लिस्ट है, और एक है Landsat 8 from 2014 to recent. आपको अगर recent image चाहिए, then you have to go for Landsat 8, okay. Clear? Yes or no? Yes. Yellow dress जो पहना, okay. If we need the satellite image of 1990 of any area, which image we have to select? हाँ, गलत होने से भी जोर से बोलिए, कोई बात नहीं.
सर Landsat 1.
क्या है उसमें लिखा?
Landsat MCC.
अभी मैंने जो बोला है लिखा है आपने? हाँ, फ्रॉम 1990 का चाहिए, कौन सा लेंगे?
Landsat TM.
TM. Okay, correct. So you have to understand, okay, these things. Anyway, so regarding this flood or hazard, this mapping, what type of satellite image we need? ये जो अभी हमने जो भी सैटेलाइट इमेज बोला है मल्टी स्पेक्ट्रल, बहुत अलग अलग बैंड्स है, इसमें क्लाउड कवर होता है. ओके, से फॉर एग्जांपल ड्यूरिंग मॉनसून टाइम इन असम, कब होता है मानसून पीरियड? जोर से बोलिए. जून, जुलाई, अगस्त. ओके, उसमें अगर हमको एनालिसिस करना है, and if we use these satellite images, then we can see in that particular time period the presence of cloud cover is there, no? So it is not possible to do the analysis because of the presence of cloud. White दिखेगा, cloud का नीचे जो features है नहीं दिखेगा. दिखेगा? आपने satellite image देखा है? Have you used satellite image in this training? Yes. Yes or no? Yes. Only neat and clean satellite images. So it's better you can also try by your own. Just register in Earth Explorer and download one satellite image, say TM or Landsat 8, say TM during monsoon period. Okay? Say the area is say Kaziranga National Park. Okay? काजीरंगा नेशनल पार्क मैंने इसीलिए बोला है कि एवरी ईयर न्यूज में हम सुनते हैं कि एनिमल्स दे आर मूविंग फ्रॉम लोअर और फ्लड प्लेन एरिया टुवर्ड्स द hillocks of Karbi Anglong, hilly areas. Why? Because of flood. Okay. So if you see or interpret the satellite image of monsoon season, then it is not possible to visualize features below the cloud cover. अगर नहीं होता है तो क्या करेगा? What is the alternative to use the satellite image? Yes, the terms are very big, but for students or the participants, if it is important, means what is the actual source? In simple words, हमें free का satellite image चाहिए. अगर purchase करना है तो बहुत पैसा चाहिए. So for students, इतना पैसा नहीं होता है. Okay, so SAR images. Okay, nowadays अभी इंटरनेट है, जियो फाइबर भी सबका घर में हो गया है. इसको बोलते हैं Sentinel-1. Sentinel-1 is SAR image, Sentinel-2 is optical, multispectral. Sentinel-1 अगर क्लाउड भी रहेगा और मतलब मानसून सीजन में, और ये क्या करता है, SAR इमेज में क्लाउड कवर नहीं होता है, it penetrate actually. Okay. So I am also using these images or the data, and the best software is SNAP, S-N-A-P, SNAP. You can you can download SNAP software and you can use S1, Sentinel-1 data. ये थोड़ा टफ है लेकिन प्रैक्टिस करते रहने से हो जाएगा. Clear? Okay. So the pixel size is 10 meter. अगर आप काजीरंगा का देखेंगे, so every week you will get the image. Okay. Anyway, so we have discussed little bit on participatory GIS, then sources of some basic understanding on data types. Now it is clear. Then the sources of data, especially satellite image. Next is very much important, that is topo sheet, survey of India topo sheet. Okay. For northeast, topo sheets are restricted in some of the areas, mainly the international areas, border areas. Okay. But the general process to get the topo sheet, suppose if you are doing some PhD work, then you have to forward one letter from your guide and you have to approach to Survey of India office. Every state they have, in Shillong also, in Guwahati just nearby Games village, okay, you have to approach. If you do not know the topo sheet number of your study area, but if you have the latitude longitude or the name of place, you have to provide them and they will search and give you the hard copy. Okay. So this is the process. Nowadays one portal is there, Nakshe portal, N-A-K-S-H-E, Nakshe portal, that is under Survey of India. Okay. 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 मैं अभी जितना बोला अभी क्वेश्चन पूछूंगा, हाँ, उसके बाद I'll proceed to maps. This is not simply writing and listening. Okay. Nakshe portal. So Nakshe portal से what generally what data we can we get from Nakshe portal? Answer. Yes.
We can get topo sheet in Nakshe portal.
Okay. So from Survey of India also we are getting topo sheet?
Yes sir, but in Nakshe portal we can get, I think so, free topo sheet, where we can get in Survey of India portal. Yesterday we have checked Survey of India portal, but
yes, you are correct, but what is the some basic difference may be there, no? The contours you will not get from OSM sheet. This is called OSM, Open Series Map. Okay. But it's useful for the students and even we are also using, and some boundaries maybe some problems are there in some of the areas. Anyway, these are useful. Okay. Then for catchment area delineation we need topo sheet as well as DEM. DEM is the, what is the full form?
Data elevation model.
Digital?
Digital
elevation model. So from the same website you will also get Earth Explorer. Okay. So how many of you are familiar with GPS, at least basic data collection? I will not show how to collect, I am just asking, only one, remaining two. Okay. So for this type of studies you have to do field work. Okay, you have to collect extensive field data. You have to record in your notebook and transfer into, say, Excel, from Excel to, say, GIS. Okay. See, there are different models of GPS, just like our mobile sets. पहले क्या था, 1100 था ना मॉडल, स्टार्टिंग में जब मोबाइल निकला था. अभी क्या है, स्मार्टफोन. So similarly in GPS different models are there, but the functions are more or less similar. But it is very difficult for the early career or for the students to buy expensive, say 10,000 is also a very high amount. So, it is better we have to search for some alternate options. So, you can write one app is there, I prefer generally, that is called GPS Essential. One blue the symbol is there, GPS Essential. The advantage is you can save new location, say waypoint, as well as if you track is the movement path whenever you go or walk. The track means रास्ता, आप GPS को ऑन करके जहाँ भी जाएंगे वो रास्ता वहाँ सेव होगा. Okay, waypoint is simply the point location. So, both waypoint means the point location and the track we can do in GPS Essential, and we can directly attach or send the data in KMZ or KML through our WhatsApp or email ID. And if we have the Google Earth, we can download and open, simple. Okay. So, I have written one manual. If you search in Google GPS handbook on GPS, or pocket size handbook on GPS, if you write Aranyak, then you will get. Okay. उसमें GPS का basic things. Actually, from last 14 years, I am giving training to the frontline staffs, university students. Okay. So, basic जो भी common चीज़ है वो मैंने वहाँ लिखा है. Okay. ठीक है, समझ में आ रहा है? Yes. इंटरेक्टिव नहीं होने से इंटरेस्ट नहीं आता है. ठीक है. हाँ, नहीं, मैं एनकरेज करता हूँ कि गलत भी हो सकता है लेकिन बोलिए आप. ओके, यही नहीं कि हर आंसर राइट होना चाहिए क्योंकि इट्स अ बिगिनिंग ना. ओके. इंटरेस्ट आ रहा है? नो? Otherwise, I'll close my presentation. Okay, anyway, this part is
louder. No one is with me.
Okay. This part is covered or not? The Excel?
Yes.
Covered, no?
Yesterday only.
Okay. Okay. What is the formula to convert from degree minute second to degree decimal? किसको मालूम है? You just come. Okay. Okay. It's visible, no? Okay, okay, thank you. This is just a revision. Actually, yesterday all of you have did this one. Anyway, so formula is equal to degree plus bracket, then minute divided by 60, then bracket close plus bracket, then second divided by 3600 bracket close, enter. Okay. Anyway, okay, this you just see dried area on 9/6 June 2020, Sentinel 2A. So, Sentinel 2 is the multispectral, means different bands are there. We can do the analysis for land use, land cover like that. Okay. And Sentinel 1 is the SAR image, radar data. So, during 2020 in eastern Assam, say in Tinsukia district, we call this event as probably disaster. Okay. Oil well में blow out हुआ था तिनसुकिया में, and the location is just nearby which national park? Dibru-Saikwa National Park. Okay. बहुत दिन तक चला. यहाँ Bagjan 5 is the location of oil well, and the date is 9/6/2020, and this one is 29/6/2020. So, before fire, this is during fire, जो भी condensate oils निकला था और गैस उसमें आग लग गया था. Okay. उसके बाद at that because this incident happened during monsoon period, no, and just nearby this area wetland is there. Okay, that is Maguri Motapung wetland. So, this oils actually affect the wetland ecosystem. Okay. Okay, anyway, so if we do some analysis of wetland area, so we have to take, so in general for wetland study, we have to consider pre and post monsoon satellite images of the same year. Okay. So, post monsoon में क्या होगा कि water spread ज़्यादा होगा, pre monsoon में monsoon से पहले पानी कम होगा ना. Yes or not? Yes. Flood plain क्या है? Brahmaputra flood plain. In most of the cases we use the term flood plain. क्या है? The areas which are means plain area from the bank of the river and towards till the wall of the वैली, ओके, और हाई फ्लड का टाइम में वहाँ फ्लड अगर होता है, so that particular area we consider as flood plain. So Brahmaputra flood plain area. So these are the Sentinel-1 or the SAR images, okay, and the size of this data is very large, above 1 GB, okay. So if we mosaic or stitch all the styles of the satellite image, then we can do the analysis for the entire Brahmaputra floodplain in Assam. Okay, so land use and land cover, I think this one is covered, no? Yes? Okay. Can you give me some say methods or the classification techniques? Supervise, unsupervised, and on-screen digitization. On-screen means generally the national projects, say under ISRO, say NRSC, they use on-screen digitization, say land use land cover. On-screen digitization means computer screen है, उसमें satellite image देखा, we can interpret the satellite image and we can create the polygon based on these different features, okay. And supervised or unsupervised classification means we have to go to the field, we have to collect the data of different classes. समझ में आ रहा है? नहीं आ रहा है? नहीं समझ में आया? Okay. Land use क्या है? Land cover क्या है? Anyone? LULC in general we use the term LULC. Land use, land cover क्या है? Okay. Okay. The natural coverage, and one is the modification. To prepare that land use and land cover, or say land cover, forest cover, we use different techniques, say supervised, unsupervised classification. First though we have to understand how to read the satellite image. Method तो बाद का बात है, पहले अगर satellite image interpretation अगर नहीं होता है, so it becomes very much difficult to do the classification, okay. Okay, I will not go in detail. Okay, so earlier sir has mentioned about this stream ordering. So most of you are from geography, no? Geography का जो है, please raise your hand. Okay, so in syllabus stream ordering का questions आते हैं, है कि नहीं? नहीं आता है? गला खोल के बोलिए. Yes or no? Stream ordering. मैं उसका क्वेश्चन नहीं पूछूंगा, प्लीज. स्ट्रेलर मेथड होता है, हॉर्टन्स 1951 like that, मुझे थोड़ा याद है. When every first order stream, when it join, the next stream will be the second order. So दो second order फिर third order, like that. Okay. So in GIS software, different softwares are there. Say ArcGIS, stream ordering tools are there. So you have to select which method you want to apply. यहाँ देखिए, first order ओके एकदम ऊपर में हिल में, यहां से दूसरा कैचमेंट एरिया होगा, ये पूरा हिल का टॉप है। फर्स्ट ऑर्डर ज्वाइन हुआ, ये ब्लैक, दिस ब्लैक इज द फर्स्ट ऑर्डर, देन वहां गया सेकेंड ऑर्डर, 2 सेकेंड ऑर्डर, देन green third order, 2 third order, then fourth, like that. We can identify the main river in the entire catchment area. Okay, and it is possible to calculate the length of stream of different orders, stream order 1 2 3 4 5 6 like that. अगर stream order नहीं करते हैं, it is not possible to identify some of the main channels. Clear? Yes? So evening में after class you have to read stream ordering, some of the concept, definition or method. Okay? Stream ordering. और इसको मैंने कैसे बनाया? There are many ways. If we how to demarcate the catchment area. So DEM data is there, digital elevation data, model data. If we have, then with the help of different tools in say ArcGIS or say QGIS, the software will process and it will show you the catchment area. But manually, I prefer manually. To delineate the catchment area using topo sheets. If you read or see, interpret the topo sheet, you will see streams, first order, second order, third order like that. Okay? And with the help of these streams as well as the contours, we can easily delineate the boundary. Okay. But one thing is there, these topo sheets are very old, especially for Assam, say 1968 to 73 का range में होता है maximum, and now it's 2020, so 40 या 50 years का difference. So in the lower reaches, the physiography may change. Okay, so in that case we have to use some of the recent images. Okay. ये एक तरह का land use, okay, of that particular catchment. Now classification, say how to prepare the land use and land cover. Some of you may know about this supervised, unsupervised or on screen, but it is very much difficult to classify built up area. Built up means human settlement, because the pixel, if you interpret the pixel of human settlement, it is more or less similar to wet sand. ब्रह्मपुत्र का जो सैंडी एरिया है, जो वेट वाला एरिया है, उसमें आपको ह्यूमन सेटलमेंट दिखाएगा जहां सेटलमेंट नहीं होना चाहिए. Okay, so as far my experience from the last 14 years, to classify the human settlements is very much difficult. Okay, so to filter or to remove the misclassified pixels, we have to build some models in. So model के लिए अभी टाइम नहीं है. So इस ट्रेनिंग का लास्ट में अगर कभी बुलाते हैं 1 hour के लिए, then I'll show you the model. Okay, that is very much important, and most of the people they are not familiar with that. Okay, क्योंकि एक मैप सिर्फ बनाने से this is not the final one. We have to do the accuracy. At what accuracy this map we may accept. So 84% is the standard accuracy. Okay. Anyway, so if we want to study wetland, So some of the people or researchers, they only study in this wetland area, but to understand the overall hydrological connectivity, all these things, we have to understand the overall catchment. दीपोर बिल कहाँ है? दीपोर बिल, दीपोर बिल वेटलैंड कहाँ है? गुवाहाटी के पास में एयरपोर्ट जाते वक्त. ओके, आप लोग सुना है दीपोर बिल? सुना है ना? इट्स वेरी फेमस वेटलैंड. So this is Guwahati airport. So one road is there. Suppose from Basista, if we want to go to Guwahati airport, one road is there, approach road, or by this bypass. So if we only study in the Porville side, it will not be very much helpful. We have to study the overall connectivity channels. So when we do this catchment approach, then जो Bahini river means various smaller streams, now it's big drains in Guwahati city. Okay, ये मेघालय से आता है. Okay, मेघालय से आके फिर दूसरा और भी river से it joins here. These are called inlets. An outlet, this is the outlet which connect the Brahmaputra river. Okay, और यहाँ क्या है? If you visit this site, sluice gate, they close the gate during high water level in Brahmaputra. Okay, in that particular time क्या होगा को fish from the Brahmaputra अंदर नहीं आ सकेगा. फिर यहाँ अंडा नहीं दे सकने से क्या होगा? फिश डाइवर्सिटी धीरे धीरे कम होते जा रहा है ना. ओके, सो lots of means other factors are important to study while considering this catchment. Okay, these are called land use. So this is only the on screen. This is not supervised unsupervised. On screen मतलब स्क्रीन में देखा और आप हाथ से डिजिटाइज करके पॉलीगन बनाया, उसमें एट्रीब्यूट दिया. दिस पॉलीगन इज built up, this polygon is water body, this polygon is agriculture, like that. Okay, and finally we can calculate the area. So 100 hectares means कितना स्क्वायर किलोमीटर होता है? सिंपल क्वेश्चन. 1 स्क्वायर किलोमीटर में कितना हेक्टेयर? आज पूछ रहा हूँ और जिंदगी में आप लोग नहीं भूलेगा. ठीक है, 1 स्क्वायर किलोमीटर इज इक्वल टू 100 हेक्टेयर्स. क्लियर? नहीं भूलना है कभी. 100 हेक्टेयर इज इक्वल टू 1 स्क्वायर किलोमीटर. ठीक है, याद रहेगा, नहीं भूलना. ओके, क्योंकि कभी कभी स्टैटिस्टिक्स इन हेक्टेयर्स, कभी कभी स्क्वायर किलोमीटर. ओके, so you have to understand this one. Anyway,
ask them to just what they understand by having a look at this.
Yes.
Land is like what it means.
Okay, so say this is the map. कोई भी आप इसको इंटरप्रेट कीजिए, ये स्लाइड को क्या चीज है? इसमें एक ही तरह का मैप 4 है, डिफरेंस क्या है? कोई भी एक गलत होने से भी कोई बात नहीं. ओके,
कैमरा हटा दीजिए. कैमरा रिमूव कर दीजिए.
ईयर 91, देन 2010 से दिस इज 2010. ओके,
टेक द माइक ऑफ.
Prominent change जो भी नजर में आता है ना, whatever is appears prominent to you, because that's how you have to learn to interpret.
Build up has been more from
Okay.
changes.
Okay.
Build up areas.
So built up is increasing, okay, and the water body, because this is only the one time image, maybe in that particular time period precipitation was less like that, okay. So water spread area कितना एरिया शो कर रहा है, किसी में कम एग्रीकल्चर एरिया किस में ज़्यादा है, कौन सा ईयर में कम है, like that, okay. So for I encourage all of you, if you do some analysis in wetland studies and all, so use pre-monsoon and post-monsoon season data, okay, for the same year. This is the standard methodology. Next, यहाँ और एक है, this one, aquatic vegetation, water spread area. So when you do the analysis for this wetlands के क्या होता है, habitat उसका कैसा है, ecosystem, what are the features generally you observe in wetland areas? आपका गांव में एक बड़ा सा wetland है, बिल है, आप गया वहाँ, क्या क्या देखा? Plants, okay, और कितने लोगों ने wetland देखा है? Raise your hand. और बाकी लोग ने wetland नहीं देखा है? नहीं देखा है?
Everybody has seen, but they don't know what we think. Right?
Okay, so say from अरुणाचल पासीघाट से जो भी है, आते वक्त असम से बस में आते समय बहुत दूर दूर में रोड का साइड वेटलैंड्स दिखता है ना, दिखता है ना, वहाँ तो इधर भी धेमाजी डिस्ट्रिक्ट सिलापत्थर उस तरफ में आते वक्त भी दिखता है, जुनाई के आसपास में भी. Okay, so in general low lying area covered with water body, उसका आसपास में क्या होता है, grasslands, okay, aquatic vegetation, और उसके आसपास में अगर ह्यूमन सेटलमेंट्स है बिल्ट अप, सो उसका कैटल ग्रेजिंग भी वहीं होता है, ओके, एज वेल एज ड्यूरिंग प्री मानसून क्या होता है, वो लोग एग्रीकल्चरल प्रैक्टिस करता है, खेती भी करता है, ओके. सो दीज आर कॉमन फीचर्स. सो वी हैव टू प्रिपेयर वाटर स्प्रेड एरिया, पानी कितना है, और एक्वेटिक वेजिटेशन का क्या है, ओके, इन डिफरेंट ईयर, say 2002, 7, 14, 18, like that.
You can go back to what you will see what this is very important. The total area here, there are two classes of areas, you know. One is blue, which is actual waterborne area, जहाँ पानी है, and the other light green is aquatic vegetation. Wetland is a combination of two, isn't it? But actual water area is actual water area. See, from the first one to the second one, actual water area has drastically reduced. It can happen for various reasons.
So this is from February, this one is from March.
So March is the driest month in Assam. One reason could be that there is no major extraction from the borewell, right? So different interpretations can be done, right? So you have to look at it. Many people question, is the deeper bills shrinking like that? Is it shrinking? Is it getting encroached and all that? From this kind of map you can actually answer many questions, but you have to do your field work properly. Then you can answer these questions. But we found that it has maintained a long-term average of from 8 to 9 on an average square kilometer in the winter. This is a question that has been asked by government to government many times. We have given an answer. It has maintained an average area of water spread area of 8 to 9 kilometer in the lean season for a long time, say for 20-25 years.
Okay, so I'll go fast. I'll not take much time. It's 1:15. Okay. So this is the satellite image MSS. मैंने बोला था Landsat MSS from 1972 to 1978. So this one is 1973. Then TM 1990, say 2010, LIS 3 image. This one is IRS, Indian Remote Sensing Satellite Data. If we see the river, okay, the course is changing. If we add 2020, so और change होगा. So ये river है Geodol. 3D view. So Geodol river, उसका हमने किया था.
It flows from the hills of Arunachal.
Yes.
And comes and meets the Subansiri and then meets the Brahmaputra. It's why he has shown this. This is one of the wildest rivers in Assam. I think people from Arunachal and Hemazi all they know. It's a very flashy river, very flashy river. You can see there are at least 8 bridges on this river. 8 different courses it maintains. It can flow to any of these courses anytime. Right? It's that flashy and that river. So without constantly monitoring its course, its channel, how it is migrating, it's not possible to plan anything, even a single bridge, a culvert, nothing can be planned. Every year it is changing, here or there. So it has to be constantly under monitoring, and satellite technology is the only effective way. This is important.
Okay, so these are the polygons showing human settlements. Okay, and this is the river. Some embankments are also there, and the agricultural patches. So based on some ranks, we prepare. Based on some ranks, we prepare the vulnerability in high, moderate, or less. Okay. We have also used DEM, digital elevation model, because the area is flat plain. Okay. So we have to use the elevation data, and we have to use the distance from, so built up areas are there. So these built up areas are at what distance from the river or the embankment. If the distance is very short or less and the elevation is less, then we have to rank high. Okay, means the vulnerability will be high. Likewise, we have to do the mapping.
This is one of those I referred to now that we did some vulnerability and risk mapping in some river. This is that. Why it is useful is that you can, if you, I mean this is old map, we need to now upgrade it. As a very dynamic river, so almost every year you need to upgrade it. If you prepare this map, you can sensitize people there that where it is safest to live for them, where it is unsafest to live, where it is moderately safe to live. You can give the same information to the district collector. So don't allow people to live in this places, high risk areas. You ask people to get settled into low risk areas or moderately risk areas with some environment and all that. So this is very important if you want to reduce the loss of life and property to people. If you want to reduce vulnerability, this kind of mapping is very important. That's the utility of these maps. And nowadays it was done almost 10 years.
Yes.
10 years back we did it. So now we have much better Sentinel has come, so much better satellite data. We have much better software, so we can do it in a much better way. And we are going to try this again next rain season in
So in 2016 also we did the entire ground survey, and this is the embankment, this is the river, this red is the built up areas, okay, it is very small areas. So we have used the Google Earth. Those, the selection of data is also important, because in this moderately resolution satellite images you will not be able to interpret.
So Google Earth, high resolution data you did. And you might question, if you look at it, see, maps are nothing unless you read it attentively and interpret it. Otherwise, it means nothing to you, isn't it? You see, all those settlements are on the river bed, isn't it? So any intelligent person will say, how come they are living on the river? It's like that only. It's like that only. There is the real circumstance, whether you believe it or not. And these people are people from Missing community. They are highly, adaptive to water. These are not their permanent settlement. They keep on slightly moving here and there. There is a core area there only. They will keep on moving from here to here. In half a kilometer, 1 kilometer square, they will be moving from here to here. So their river is playing hide and seek with them. They are also playing hide and seek with the river. So they are so adaptive. They can understand. They react very well to the river. They can proact also. They can anticipate how the river will move. So based on their traditional knowledge, and they will, anticipating that, they will slightly move behind or right or left for that particular season and try to be safe. So this is a beautiful example. We have done a lot of work in that area. We have written a lot about that area. So this is how there is a play between vulnerability and adaptability of people. And this is a very good example of coexistence of with river and floods. Right? They are not escaping from that area. They are not migrating to any other district. They are remaining there. They are not afraid of, because they are highly adaptive. Right? They suffer a lot, but they have the resilience also. Right? Otherwise, in any other country, nobody will allow you to live on a river. And see the river, see how many, it's a highly alluvial river, you see, it's braiding. It can flow.
Some
in any of these.
breaching locations are also there.
Also there.
But they are.
So it's a highly volatile situation, but people are living there.
So based on this, as well as ground data, we tried to show the vulnerability classes in different areas, in different villages, using grid based. Okay, so every grid is there. So we have calculated different scores, and we have rank and color, means which are the areas which are highly vulnerable. Suppose if you see this area, okay, these areas.
So this was the situation in 2016. In 2022, we are going to repeat this exercise, and I swear you will see, if we have another opportunity in the next year, I will show you the situation is completely different. The most vulnerable areas are also shifting. People's settlements are also shifting. Right? They don't need a scientist to go and tell them what to do. They know what to do actually. River is changing, they are also changing, will give a very different, but nobody is escaping. Now neither the river is going away nor the people are going away. They are adapting to each other. I think it will be very interesting when we do it this season, November and December. Yeah.
So this is just a change of some chore areas in Brahmaputra river.
Chore river and island.
Because in Brahmaputra river islands you can see agricultural fields as well as human settlements in most of the areas. Okay. So this is in Dhubri district. So I'll go fast. Okay. Majuli, Majuli. Why Majuli is famous?
Why Majuli is famous?
Why?
Loudly.
River island in the world. Okay. So we have to also do some scientific study.
How large? As I say, as scientists, how large?
Always we are saying this is the largest river island in the world, but these landscapes are changing, no? So we have to do the analysis. So 1934. So Majuli and adjoining river landscape during 1934. This source is there. So based, okay, 1834. So based on this map source, we have tried to say
reconstruct that till now.
What was the land mass and what is the present land mass area, like that. So this is like Majuli is surrounded by rivers in most of all the sites. Okay. So on the south, Brahmaputra river. So in 1950, 63, 70, like that, if we do the continuous, means after a certain interval, if you do the temporal changes, then we can easily calculate the landmass area. Okay, it's changing. And we can also measure using different cross sections, measure the
how the river is approaching the river. I mean, the main problem of all these river and island is erosion. You know that the river is cutting the land. That is the biggest problem to their existence. So you have to know scientifically. You have to tell the deputy commissioner or the chief minister of Assam that how much area has been cut in last 10 years, last 20 years, last 30 years, last 100 years. So these are things only that can be done. So
so we have to measure the distance. Okay, here these are the cross sections. I will go fast. Okay, Kobo Chapuri. I think people from Isyang, they are familiar with Kobo Chapuri. Poba Reserve Forest, yes. So just back of Poba Reserve Forest, you can see Kobo Chapuri, no? Okay. So in 1977, the area was more or less in bigger size. The landscape means the landmass area. But if we see in 2019, if we update with 2022, then maybe it will further decrease. Okay, because the presence of human habitation is there in Kobo Chapuri. Okay, so
it has reduced almost by 80%. So it's a highly dense area. Entire population is in high danger. See, this landmass in a river island is getting, show them the area first and second. Previous
this one.
Total area you see 91.35 square kilometer. Now 10. From 91 square kilometer, it has reduced to 10 square kilometer.
Now it's an island. Kopo Chapuri,
yeah,
yes, Chapuri.
From this much, it has become this much. Now, this phenomenon, it means a lot of things. There were almost 1 lakh population. There are still 30, there are still no 7,000 population. Where have the people gone? So it has created a huge problem of human migration from that area to various other areas. It has made people poorer. It has created poverty, social migration, social conflict, everything, right? So if you do some different kind of field work, we can also throw light on other aspects of this problem like migration, etc. We didn't get into that aspect because we just wanted to see what is happening to the landscape, right? But you can also, look at other aspects of the problem using geospatial.
Okay, so this is the status of Kaziranga National Park as well as the additions. This is only the core area and these are some of the additions which are along the riverine landscape. So this is just a land use land cover. Okay, then every year we hear the news of Kaziranga National Park that animals are moving due to flood. Okay, so if we want to do some water spread analysis during monsoon period, say in 2020, 3rd July, 13th July, 15th July, 22nd July, 27th July, 20th August, like that, if we see or compare, then we can easily do the analysis. Okay, what is the actual spread? Okay,
and we can also see the trend. Is the inundated area increasing gradually for last 10 years, 11 years, etc., etc.
And these are some of the simulations we can do in GIS software. Suppose if we provide this much of, if we write this much of water level, then what will be the inundation area? Okay, we can do something. Okay, so Pobitora Wildlife Sanctuary is there just nearby Guwahati in Morigao district, and this is famous for rhinos because this is the world's highest rhino density in the world. Okay, and during monsoon season, most of the areas in Morigao actually inundated. So if we do some analysis using SAR data, radar data, if we do the analysis, and we can easily see the what are the areas which are say inundated, and these are the uninundated areas or highlands. Okay, so the last slide, I did one study in Jammu. Okay, so famous wetland is there, that is Ramsar site. One is Surinsar and Mansar Lake. Okay, so we tried actually, the lake is small, and we tried, we prepared different grid of say 100 meter, okay, 100 meter grid using GIS, and we upload this grid file in GPS. Okay, and this is also a tourist place. So with the help of paddle boat, so we tried to take the depth inside each grid. It is not compulsory to go at the center of each grid, but just inside, and one instrument is there, depth measurement. Okay, just like torchlight, if we take the measurement, okay, just we have to dip this into water and it will show us the reading. So individual grid, I have the IDs and have the water level. So if we do the simple mapping, then we can say that okay, dark, this one, the water depth is 40 to 45.6 meter, it is very deep. Okay. So it's up to our study, what type of study actually we need. So we can customize our study and we can fulfill the objective. So thank you very much. So my email ID is arup@aranyak.org. If you need, or if you want sometime means to talk, if you face any difficulty, I am not an expert, I am just doing the basic things. arup@aranyak.org. Arup, I will write. Small, huh? arup@aranyak.org. Phone number 7577-836-104. Okay, 7577-836-104. So okay, thank you. It's already late actually for lunch.
But even then, if you have any important questions to Arup, and
yes,
even to me, if you have, we'll be glad to answer.
And Anini se kaun tha? Anini, from Anini or Tuting? You have to give your phone number, okay? and cotton se do. Okay. Any questions?